Here we want to find the integral of x squared divided by 1 plus x squared squared. This integral contains the expression of 1 plus x squared. We could think of it as the form a squared plus x squared. And if we have the a squared plus x squared, then the suggestion is let x be a tangent of theta, even though this has a square root right here. But whenever we have 1 plus x squared to any power, this suggestion is still valid. So even though it has x squared here, but we have just square here, the suggestion is still valid. And so we will let a squared be 1, or a will be 1. And then from the suggestion, we will let x be a times tangent of theta. But a is 1, so we get 1 times tangent of theta, which is tangent of theta. So x is equal to tangent of theta, which means theta is tangent inverse of x. So we have x equal to tangent of theta, then the derivative of x with respect to theta, derivative of x with respect to theta, the derivative tangent is secant square. And so we get dx is equal to secant square d theta. So let's rewrite the expression 1 over x squared in terms of theta. X is tangent of theta. X is equal to tangent of theta, so we have tangent of theta squared, and then we have square right here. From trigonometry identities, 1 plus tangent squared is secant squared. So we have secant squared, so it'll be secant to the 4th. And so the integral now becomes this. X squared will be tangent squared, because x is equal to tangent of theta. 1 plus x squared is secant to the 4th. Dx is secant squared theta d theta. And then here we have secant squared dividing by secant to the 4th. So we end up with secant squared on the bottom here. And so we have tangent squared dividing by secant squared. Tangent squared is sine squared over cosine squared. Secant squared is 1 over cosine squared. So we get sine squared over cosine squared times the reciprocal of this. Reciprocal of 1 over cosine squared, which is cosine squared over 1. Cosine squared dividing by cosine squared, that would be 1. So what's left is just sine squared. So now we need to find the integral of sine squared. So we want the integral of sine squared. Recall that from trigonometry identities, sine squared is 1/2 minus 1/2 cosine of 2x. So this is from trigonometry identities. Antiderivative of the constant 1/2 is 1/2 x. And then here we get minus 1/2. Antiderivative of cosine of 2x, or the integral of cosine of 2x, is 1/2 sine of 2x. So minus 1/2 is minus 1/2. And then the integral for, or the antiderivative cosine of 2x is 1/2 sine 2x. And so we end up with 1/2 x minus 1/4 sine of 2x. So the integral of sine squared of theta, instead of x, we have theta. So we have sine 1/2 theta minus 1/4 sine of 2 theta. And recorded from trigonometry identities, sine of 2 theta is 2 sine theta cosine theta. Sine of 2 theta is 2 times sine of theta times cosine of theta. So we get 1/2 theta, and then a 4th times 2 is 1/2. Sine of theta cosine of theta. And now we need to rewrite this in terms of x, since the original problem was in terms of x. Earlier we had x equal to tangent of theta, which means theta is equal to tangent inverse of x. So in the place of this theta right here, we can put tangent inverse of x. But we need to find sine of theta and cosine of theta. Recall that tangent of theta is opposite over adjacent. But we have tangent of theta is equal to x, which is the same as x over 1. And therefore the opposite side of the angle theta will be x, and the adjacent side will be 1. So here's the angle theta. The opposite side will be x, the adjacent side will be 1. And so we need the hypotenuse. So we have x squared plus 1 squared is equal to the hypotenuse squared. So this would be x squared plus 1 equal to h squared. And then take the square root of both sides. We get h to be the square root of x squared plus 1. So the hypotenuse would be the square root of x squared plus 1. Sine of theta is opposite over hypotenuse. So the sine of this angle will be x over the square root of x squared plus 1. Cosine is adjacent over hypotenuse, so it's going to be 1 dividing by the square root of x squared plus 1. And so we have the original integral. We have 1 is equal to 1/2 theta minus 1/2 sine of theta times cosine of theta. Theta is tangent inverse of x. Sine of theta is x over the square root of x squared plus 1. Cosine of theta is 1 over the square root of x squared plus 1. So all of this 1 times x times 1 will be x. And the square root of x squared plus 1 times the square root of x squared plus 1 is just x squared plus 1. And then we have the 2 right here. So this is the answer.